Good afternoon, everyone. Good afternoon. Hope all is well. Everyone's doing all right. Sorry for running a few minutes behind. Got caught up in a little bit of traffic, but I made it. Made it before 15 after, right? So let's see where are we getting started today. So yes, we did this last class. On the magnitude. Same thing we did last class. Okay, so we're starting here. Let me write something that's a little better. So last class we had started 7.6 and we ended here with finding the magnitude. So let me see if this is worth going over. I think this was just another example, but we can start right here. Just as a recap of what we did last class. I'm gonna write this a little better. All right, so 7.6 was vectors. And we're going to finish off 7.6 today. May get to 7.7, but we'll see. We want to find the magnitude. And this is the symbolism for the magnitude of vector V. And so we're going to plug in our values into this formula. And X1, Y1 is coming from your initial point. X2, Y2 comes from your terminal point. All right, so just walking through it, they give us P to be 3, -2, and Q to be 4, 1. Plug those values into the formula accordingly. So Y2 will be 1, Y1 will be -2. Make sure you don't lose that negative here. So it's a 1 minus -2. And then X2, I meant, why did I do Y? I did Y. Well, it didn't matter. I made a mistake and did Y's first here. And then X is first here, but it'll be all right. So then X2 is 4. X1 is 3, so 4 minus 3. And so that'll be 3 squared plus 1 squared. 9 plus 1, square root of 10 would be your magnitude of vector V. And then, of course, if you can simplify this, you would. So. All right. Everybody okay with that? All right, see somebody in the chat. Come in. 1 second, I was trying to fix this. All right. All right, so if a vector v is 7i plus 3j and vector w is 4i minus 5j, and he wants to find 6v minus 3w, and you would treat it the same way that you would, any algebraic, practice. You plug in plug in 7i plus 3j for v, and then plug in 4i minus 5j for w. Then we would distribute, combine our like terms. All right. So 6 times 7, 42i. 6 times 3, 18. Then we distribute -3. And once again, you see how our basic foundational algebraic practices continues to follow us as we go throughout, pre-calculus to trig to, eventually calculus. So you always got to make sure you hold on to the algebraic practices. Algebra is the foundation of all of your sciences and upper level math. So 42i minus 12, and that should be right there. 42i minus 12i give me 30i. 18j plus 15j will give me 33j. Just combining like terms. Any problems with that? Mhm. Next one, they tell us to find the magnitude of V, but notice they give us our vector information as part of a linear vectors, as a linear vector, 7i plus 3j. If you go back to what we had before, we had our ordered pairs. And so we had to lean on this relationship. But here, when you have it set up this way, 7i plus 3j, you can just square the 7, square the 3, and add them together. That would be 49 plus 9, that would be 58, square root of 58. Everybody good, everybody straight. All right, so this next piece is going to be new in comparison to what we talked about last class. So finding the unit vector that has the same direction as a given non-zero vector. All right. So for any non-vector v, the vector is v over the magnitude of v. So don't forget the magnitude of v is just one number. And so that's going to be a unit vector that has the same direction as v. And then this statement is just a reiteration of the symbolism you see. Find the vector, this vector divided by its magnitude. All right. So we're looking to find a unit vector in the same direction as vector v. Well, v is equal to 5i plus minus 12j. All right. So first, we want to find the magnitude. We just finished doing this before. So 5 is going to be a, 12 is going to be b. We can square 5 and square 12 with negative 12. And that'll be 25 plus 144, which will be 169. And the square root of 169 is 13. So the magnitude of vector v is 13. Any problems, any problems? So now we're going to divide b by the magnitude of v. So v over the magnitude, same thing as 1 times v, 1 over the magnitude times v. So that's 1 over 13. V was 5i minus 12j. And then multiply each term by 1 over 13 gives you 5/13 I minus 12/13 j. Questions? Any questions? All right, so writing a vector in terms of its magnitude and direction. The components A and B of a vector can be expressed in terms of the magnitude of V and the angle theta that V makes with the positive x-axis. And theta equals direction of angle V. All right, so we see cosine theta is equal to A over the magnitude of V. Sine theta is equal to B over the magnitude of V. Or you can rewrite it and say that A is equal to the magnitude of V times cosine theta. B is equal to the magnitude of V times sine theta. Same relationship, just written different ways. All right, so then don't forget another way we can use this, because if vector is equal to A times I plus B times J, we can plug in this for A, this for B into our linear representation of our vector and have this expression here. A vector that represents the direction and speed of an object in motion is called a velocity vector. All right, so try to put this into an example. It says the wind is blowing at 20 miles per hour in the direction of north 30 degrees west. Express its velocity as a vector in terms of I and J. All right, so once again, the wind is blowing at 20 miles per hour in the direction of north 30 degrees west. So when we look at theta, remember if you go back to what theta represents, what is it? Theta D makes with the positive x-axis. So when we go here, we talk about northwest 30 degrees. So that takes care of this part of it. But we have to consider coming from the positive x-axis. So that's why it would be 90 plus 30 degrees. So coming from positive x-axis, that's 90 degrees plus the 30 of going northwest. So that would be 120 for our theta. And then our magnitude speed is just 20 miles per hour. So we're okay with that. Okay. So then from there, you just go ahead and plug in here what we've already labeled. So that's 20 cosine of 120 degrees I plus sine plus 20 times sine of 120 degrees J. Cosine of 120 is negative 1/2. Sine of 120 is square root of 3/2. Simplify that. That would be negative 10I plus 10 square root of 3J. So that just represents the wind's velocity in terms of I and J. Any questions? Any questions? Okay. So that's it for 7-6. Let's see. See how long. 7. Yeah, we can start 7-7 and then may or may not finish. Are we okay before we go to 7-7? All right, so dot product. When we look at vector V, we call that A1 I plus B1 J. Just signifying that we have more than one I, A and B component. Because the components from W, vector W, we'll call that A sub 2, B sub 2. So they are vectors, the dot product, which is V dot W, is defined as follows. There's just A sub 1 times A sub 2 plus B sub 1 times B sub 2. All right. So if vector V is 5i minus 2j, vector W negative 3i plus 4j, you want to find the dot product of V and W, and then W, V. Notice it gives us the same thing. So you just do, if I want to label it, so A sub 1 is that 5, B sub 1 is negative 2, A sub 2 is negative 3, B sub 2 is 4. And so you just plug them in accordingly. And in both cases, you get negative 23. And so they were just emphasizing that relationship here. Then if you do dot product of V and V, that would be 5 times 5, A sub 1 times A sub 1, B sub 2 times B sub 2, that'll give us 29. Any questions? Any questions? Oh, this is in the chat. Oh. So properties of dot product and W are going to be vectors for us. C is going to be a scalar. So with our previous example, we just showed you how that one works. Dot product of U and V is the same thing as dot product of V and U. And if you were trying to apply the dot product of U, well, how can you say it? U dot the quantity of V plus W, you can distribute it and apply the dot product to U and V, and then U and W, if I can get it out. But it equals to the same thing. Dot product of U of 0 and V is going to be 0. dot product of V in itself is going to be the magnitude squared, magnitude of V squared. Then C, which is a scalar, times U dot V is the same thing as C times U dot V, or U times U dot CV. And we see it right here. If I go up too far, somebody still copy and let me know. All right. So we have an alternative formula for the dot product. If V and W are two non-zero vectors and theta is the smallest non-negative angle between them, then the dot product of V and U, so V and W, is the magnitude of V times the magnitude of W times cosine theta. All right. So if we take this formula right here and solve it for theta, the formula for the angle between two vectors would be cosine theta is equal to the dot product of VW over the magnitude of V times the magnitude of W. I don't know why I circled these. I'm pretty sure there's a reason. All right, scrolling up, everybody good? All right, so we want to find the angle between vectors v, which is 3i minus 2j, and vector w, which is negative I plus 4j. All right. So, and I see why I circle these pieces now, because we have 3 pieces that we need to find. Circles there. All right. So first thing we do is find the dot product of v and w. So we can take 3 times -1. It's a times a sub 1 times a sub 2, plus b sub 1, which is -2 times b sub 2, which is 4. That's -3 plus -8 equal to -11. And then we need to find the magnitude of v. Where you square a and square b, add them together, take the square root of both. So to take the square root of the sum, I should say. So that's 3 squared plus -2 squared. It's 9 plus 4. And square root, well, 9 plus 4 is 13. Square root of that. Square root of that's 13. Square root of 13. And then the last piece, the magnitude of w, is -1 squared plus 4 squared. Get my square root of 17. Before we plug in those 3 pieces, any questions? All right, so to find theta, you do cosine inverse of -11 over the square root of 13 times the square root of 17. You can simplify that denominator by doing square root of 13 times square root of 17, which is square root of 221. Or you can just really throw it in the calculator right here if you want to. As long as you have that capability in your calculator. And then the answer will be 137.7 degrees. All right, any problems before we go to the next thing? Mhm. All right, parallel and orthogonal vectors. Two vectors are parallel when the angle theta between the vectors is 0 degrees or 180 degrees. Mhm. If theta is 0 degrees, the vectors point in the same direction. Theta is 180 degrees, the vectors point in the opposite direction. Very good. It's just a visual right here. So two vectors are orthogonal when the angle between the vectors is 90 degrees. Everybody good, everybody straight. All right, so the dot product and orthogonal vectors. Two non-zero vectors, v and w, are orthogonal if and only if, that's what IFF is short for, if and only if the dot product of v and w is equal to 0. Because 0 and the dot product of 0 and v is equal to 0, the 0 vector is orthogonal to every vector. All right, so here we have are the vectors orthogonal. So remember the way that we can gauge that, go back here, two vectors are orthogonal if when you apply the dot product to the both of them, it equals out to give you 0. So that would be the way you would measure that. So we have the components of our vector v to be 6 and -3. Components of vector w, 1 and 2. And we plug those into the dot product formula accordingly. So 6 times 1 plus -3 times 2 ends up giving us 6 plus -6, and that is 0. So that means vectors v and w are orthogonal. Questions. Let me see, do I want to go into projection? I think this is a good place to pause. I don't want to get into that and then have to stop in the middle of that. So this is where we'll pick up next class on 7-7. Like I said, don't want to break up that discussion into 2 classes. So before we close out, questions, concerns, comments, anything, anybody? I'm good, everybody straight.
No. Games. And we're really great.
Fine. All right, take care, sir. Take care. All right, everybody done copying before I close out? Everybody good? I see some in the chat. Proctored tests. All right, so let's look at, so next class we'll most definitely finish out 7-7. At the earliest, we're looking at next Thursday, not this one coming up, but the following Thursday at the earliest, because I like to close out the chapter, then give you at least a day to review, review day where you guys will come in, ask whatever questions you want. So let me go here. Okay. So today is the 22nd. And next class will be the 24th. So we're looking at 29th and 31st. So we did 7-6, 7-7. They finish all 7-7. So we'll review next that class next Tuesday. And then here we'll be looking at the test. Unless you guys ask me so many questions on this day that it bleeds over into the next day, I don't have a problem with it if you guys have the questions. Let's see, someone says in chat.
What's the document test?
Say that again now.
What's the
Oh, you went mute. You said what's the and I didn't hear you. Couldn't hear you.
what's the Parker test?
Oh, well, we talked about how I do have to start proctoring some tests. I have to proctor some assignments for you guys. That's what we are responsible for, just like we would in a regular class period, if we're doing face-to-face. So up to this point, you've done chapter 5 and chapter 6 tests unproctored. So chapter 7, I mentioned that we will do proctored. So that means that you guys will come into Zoom, enable your camera, show your ID, and take the test during this class period. And so that's how we're going to do chapter 7 tests and chapter 11's test as well. Chapter 11's test won't be that bad. Trust me, talking about series and stuff. I think you guys are going to be all right with chapter 11. We just got to get past chapter 7. And, but yeah, so that's what we're talking about. And I'm going to send you guys a email with directions on how we're going to handle it, what it will look like for the makeup and all of this stuff like that. But we were talking about getting to a place where we were done with chapter 7 and then going into deeper details with that. So let's see how much time we got time. So just to let you know how it will play out, option 1 is taking the test in class. And full 100% is an option for you or available to you to make. Option 2, let's say if you don't do as well as you like on option 1, or you just know you weren't ready for it. This would be on your own. And the highest score possible on this test is 85%. Now, I have to do something like that to keep the integrity of the class or the academic integrity, whatever you want to say. But 85%, the way my class is set up, will not stop you from getting an A out of the course. It's just something that I have to implement if somebody were to audit my course and they say, well, there's no real penalty for not taking it or whatever. So we have to put something in there to make it at least seem as if there was a proctored test and I gave you at least an option or ability to make it up. So the highest you can get on the test, that the makeup test, is 85. But once again, having an 85 test average will not stop you from making an A out of the course if that's what you desire. Not doing your homework and not having at least 85 test average will stop you from making an A out of the class. So that's what it's kind of a way of putting a little thing in there, but it really don't hurt you guys. So that's what we're looking at as far as our test is concerned. On the earliest, we're talking about the 31st. As a matter of fact, I may have found out yesterday that I'm going out of town. I just thought about that. We can't do it on the 31st anyway. It may have to be pushed to April 4th. I'll confirm and make sure, but the test may be on April 4th. So you that just may be a free day. Nothing going on, but you guys can just, make sure you're right going into the weekend and all of this stuff like that. Let me confirm. I think I'm going out of town this day. But
Mr. Tucker,
yes.
I have a question, but like after the class.
Okay, not a problem. And then somebody just
Okay,
asked.
bye.
All right, take care, sir. Do the reviews, give you extra credit. Yes, so if you get a 85 or better on the reviews, that will add 5 points to your test. So that's still in play. All right. But we'll talk about this more as well. Yep, not a problem. Any other questions before we close out? I know I got one that I'm staying back for. Yes, I did see your email. I'm going to get to it. I got to get caught up on them. So I'm going to get you though. All right, you guys have a good one. Take care, and I'll see you next class.
Mr. Tucker,
Yes,
do I
sir.
have to complete my 7-3 homework?
No, I'll just leave it up there for extra credit. We're just going to keep it at these 4 sections and just roll with it that way. Thanks for asking.
Thank you.
Mhm.
Have a good day.
You the same.
Thank you very much. Goodbye.
All right, take care.
I had a quick question, Professor Tucker.